Well, thank you guys again for coming, and thank Green Pages, and here you guys go.
Thank you.
Thanks. All right, so I am David Jones. This is Chris Williams. We are from Green Pages. For those of you who don't know, Green Pages is a cloud solutions provider and general technology integrator, implementer. We're based out of Kittery, Maine. Offices all up and down the East Coast, Boston, New York, Atlanta, Tampa. So we are here today to discuss elasticity and autoscaling within AWS. Mount it up so I don't have to hold it. Can y'all hear me okay without the mic? Yeah. I'm an active talker. I don't like to stand in one spot, so that's all right.
Move around.
You don't want to sing?
So who are we? Why are we here to talk to you about AWS? Again, I'm David Jones. It's Virtual Jonesy on Twitter if you're so inclined. I'm the practice director for the hybrid cloud data center practice at Green Pages. That's generally speaking VMware, AWS, hardware for the on-prem side. I am an AWS Solutions Architect Professional, a VCIX data center, and all of the various VCPs with the exception of desktop. I don't do end user stuff.
So do we.
That's right.
And my name is Chris Williams. On Twitter, I'm at Mistwire. I'm an enterprise cloud consultant for Green Pages. I am also an AWS Solutions Architect Pro. I have all of the letters from VMware as well. And Kyle and I do work for vBrownBag. We both host and present for vBrownBag. If you guys are familiar with that, it's super fun. And I also blog at Mistwire as well. I have a lot of how-tos on actually how to do a lot of the stuff that we're going to be doing tonight on there. So they're like step-by-step walkthroughs, screen caps, click this, touch this, do that. And I generally have a fun time doing that as well. So for the agenda for today, what we're going to do is we're going to break this down into two separate sections. I'm going to do the front end. Josie's going to do the back end. I'm going to talk about ASG. We're going to go through it in the steps. We're going to play this game I call Be the Packet. We're going to walk from the end user all the way down to the web server and all the little hops in between, and how the logic is spelled out between all of it. And then during the live demo phase of this, we're actually going to show you an environment that we've built that is self-healing, that is auto-scaling, that has mins and maxes and does all the things. And we're going to break it. We're going to break it, kick the legs out from underneath it, and then watch it reheal itself and spin itself back up, and watch it pop from different availability zone to all over the place.
It should be noted too, Chris and I have been accused of bickering like an old married couple. So, so it should be entertaining if nothing else.
That is not true. I will refute that. And then Josie's going to do the RDS piece of this. We're going to talk about the multi-AZ on the back end of it. We're going to do the live demo. We have made the appropriate demo god sacrifices in terms of sleep and weekends. So hopefully, fingers crossed, the live demo will go well. The rule is you never do a live demo. We're going to flaunt the rules. So, auto-scaling 101. So, quick show of hands. Do we have like ASG gurus that they don't know why they're here, and this is they're black belts, and they're going to ask me super hard questions? Anybody? Oh, awesome. Okay. Brand new to auto-scaling, here, want to learn what it's doing, don't have the first idea about it. All right, and other people that somewhere in between, you've heard about it, you know what it does, but you want to get into the nitty-gritty. Excellent. All right. No experts. Fantastic.
Beautiful. Don't believe anything we say.
That's right. All right, so this is the one thing that I'm actually going to read direct from the website. Amazon EC2 Autoscaling helps you to ensure that you have the correct number of Amazon EC2 instances available to handle the load for your applications. Load has been bolded on purpose. That load is a different definition for every single customer. Load can be high CPU, load can be a bottlenecked SQS queue, load can be surge queues. What was that other one?
Spillover count, surge queuing.
Spillover count, and any number of custom metrics. Load is a very asterisked term in the industry, simply because you can get into religious wars about why is this thing going slow? Oh, it's load. Oh, where's the load at? Oh, we need more storage. I know you guys know what I'm talking about. So, an auto-scaling group. An auto-scaling group is a group that scales automatically. And we're done. Thank you. Thank you all very much. We're finished. All right. So basically what this allows you to do, an ASG allows you to specify a minimum size, a maximum size, a desired number that you want alive, and that's basically the entirety of the definition of your ASG. Your min size is what it tries to maintain, your max size is what it will never exceed, and your desired state is, again, what it tries to maintain. If you have a desired capacity of 2 and you terminate one of your instances, it'll spin at another one. It's not hard. That part isn't hard to grasp. This is the Visio icon for an autoscale group. So when we're showing you the diagrams and everything, you'll see the 3 squares and you'll go, oh, that's the autoscale group. The elastic load balancer is the one with the 3 little fingers going off the little triangle thing. I'll point it out to. So, as you guys know, AWS changes the interface every other day. It's ridiculous. They change icons, they change interfaces, they change consoles. What we're going to be doing is we're going to be concentrating on these 2 sections right here, the load balancing section and the auto-scaling section. Now, as of April, they popped up a new interface called the AWS Autoscaling interface. We're going to do it the old-fashioned way. That way you actually know what's going on behind the covers. This is a faster and easier way to do it, but you don't really get into the hows and the whys of it. And you can do it that way. It's the exact same concept as the VPC. You can make a VPC from scratch and really know what's going on with the internet gateways, or you can just hit the button that says make me a new VPC. You can do that, but the second you need to change it, then you don't really know what's going on, and then you script your security groups and everything goes to hell. Sometimes. Okay, so the next question is, all right, this is all great. Why do we need an autoscaling group? So there's basically 3 different reasons. The first one is the classic variable load pattern that any business has. Unless you're running an Active Directory controller, a domain controller, and it's just trundling along at 2%, you're going to have spikes, you're going to have troughs. Things are going to go up and down your environment. Sometimes the spikes exceed the capacity of your environment, and then historically you'd have to go out and buy more servers or VMs and then provision more VMs on top of your hosts. With autoscaling groups, as you exceed the load, boldface, of your environment, the autoscale group spawns up more instances for you. You start paying for those instances when they come on. You don't pay for them when you're not using them. So you have your H&R Block, you have your tax season, you have a massive spike in March and April, and then for the rest of the season you have literally nothing. You don't want to be paying for the compute for the time that you have a dip. Christmas time, quarterly reviews, all that stuff. So that answers the variable load pattern. The next one is the classic hardware or software failure. If the instance that you're running on, if the host underneath it blows up, you need something else to run on. VMware does this fantastically with vMotion. Shout out to Ray, shout out to Kyle. And AWS does it fantastically as well. They respawn your instance off on another piece of hardware. You don't have to worry about it. It comes out. Software failure, I have an asterisk on that, simply because some software failures will be noticed by the load balancer's health metrics. Other ones will not be noticed. And this also depends upon what you're setting up as your health metric. A software failure, for example, if you're running Apache and you've got your health metric looking at a website and you're looking for the website to respond and get you a 200 back, if your Apache works, then that is a noticed software failure. It'll kill the instance, it'll respawn a new one, and bring that up and wait for that to be healthy. If you use a health metric like ICMP, and you're pinging the box, and Apache dies, the health metric doesn't care. It's going to keep that box up thinking that it's healthy. So software is an asterisk, and that's actually one of the gotchas too. You always want to make sure that you tune your health check to make sure that you're looking at what you think you want to be looking at. And we're going to do it in just too. The last one is cost optimization. If you don't have a server, then you're not paying for it. And that's your CTO right there. I mean, excuse me, your CFO. And he's trying to hold on to his money. He doesn't want to let you have any of your money. And so if you're not paying for the server, you're not. If you don't need to have the load for it, you don't want to pay for the server. Okay. So is that visible or is that unreadable? And
Unreadable.
Can you do something with the fonts?
the answer is no.
How about contrast?
Can we adjust the contrast a little bit? Is that a thing that can be done on the fly?
Tammy, is that possible?
Just contrast on the screen?
Yeah, from the projector, can we sharpen it up a little bit?
Everybody just get on stage.
Yeah.
Everybody, come on.
Further, come on.
There's room?
Until that time, I'll entertain your chat stands.
Probably a better luck doing it on the computer than check it, we'll try it.
Okay, so what we're looking at here is, these are the two groups, the load balancing group and the auto-scaling group that I was talking about before. What we're going to do is we're going to,
So that works.
You can see the whole screen.
Yeah, the focusing is good.
how can you? As you can see right here, we have the,
That works.
okay, it is what it is. So we have these are the four food groups when it comes to auto scaling and elastic load balancing and having a front end self-healing environment.
Oh, it didn't like that either.
Adjust.
Adjust. Contrast? Or
Sharpness.
where's that AV high school guy I was asking for that for?
Red. Red.
Come on out here.
Yeah, I know.
Very nice to you.
It's not virtual, I can't do it anymore.
Other way?
Can you try it? Ooh.
There you
That
go.
looks pretty good.
Hey. This is like CSI, enhance, enhance, enhance.
It's not bad.
Cool.
You turn on that?
Is that better? Is that, you guys,
Yeah,
you comment with
contrast,
that?
can we make that positive, go in the positive side?
Bring up the brightness.
Right, it's still, yeah. Sorry, this is great.
I'm working on it.
I screwed it up, I'm sorry.
You distracted.
Threw me off. Because you have a degree and I didn't need to look at your projector.
Oh, no, I can't use my cell phone.
I have the hardest time with our office phone system. I say that so I don't have to call Joe.
She said brightness go the other way?
Brightness go the other way, the positive. Slide over.
Maybe too far?
That's too far. Okay.
We say as we stand right on top of it.
Make it positive.
That's worse. That's worse.
That's from that too, yeah.
There we go, there we go.
Yeah, perfect.
All right, I mean, you guys don't have to read, like, I mean, there's not a quiz after this, so.
Thanks.
All right, thank you. Okay, so building of the auto-scale group. The launch configuration loops into the auto-scale group. The auto-scale group then dictates the target group, and the target group is then monitored by the load balancer. I'm gonna walk through all this. So basically, the launch configuration is the exact same process as when you are building an EC2 instance manually. Like when you go into EC2 instance and you click launch config and you click through yada yada, add your dist, all that good stuff. That is exactly what happens in your launch config, with the exception of when you click finish at the end, it actually doesn't do anything. It just stays there. The launch config is then waiting for you to attach it to an auto-scale group. So your launch config is basically all of the wrapper of your EC2 instance, whether it's Linux, whether it's Windows, it doesn't matter. It picks your AMI, it picks your instance profile, your key name, whether or not you want to use EBS optimized, the instance type, and security. Now, the big thing that's really cool about here is your user data. What that does is this sets up in Linux. This is your script that runs at the very beginning. It does all of your installs of all the stuff that you want to have on your box. It does your EFS mount points if you have something on the back of it. Any command that you want to run on every single box when it turns on, this takes care of it. What we've done in our environment here is we basically have the PHP file on the database side mounting on the fly as it goes here. So any changes that are made on the back end then immediately get propagated out to any box that gets turned on or that is already spun up and running in the environment. And then we turn it back. So the launch config is then fed into the Autoscale group. The Autoscale group looks at the launch config to decide what's going to be running. The launch config details are the scaling policy, which is your actual trigger. The scaling policy is your trigger based upon your defined load metric. Going back to load now. The load metric is CPU. So in our environment, we have the scaling policy set to if the CPU exceeds 80%, kick off another instance. If that CPU then exceeds 80%, kick off another instance. If that's et cetera, et cetera, et cetera. So the more people that you have hitting the box, the more load you're incurring, the more servers that you then have. Your load balancer will then take all of those users and spread them proportionately across all of your different instances. The target group is then the target group of the ASG itself. So when you turn on an environment, you want to have the group, the Autoscale group, defined by a parameter, and that is your target group. And that then feeds back into the load balancer. And this is another piece of the gotchas that I want to talk to you guys about, that health check grace period. Different boxes take different amounts of time to turn on. And you will get bit in the butt, and I've got a slide to talk about this a little bit later on. 300 seconds, is that 5 minutes? 5 minutes is more than enough time for certain loads to turn on. Other times it's not. You definitely want to measure this for your environment as you're bringing this up. This is a very common gotcha.
So actually, before he moves on, I got bit by setting up the demo environment. I was trying to crank the numbers down as low as possible so that the demo would be quick and you guys could see stuff without us standing around having to talk while we waited. And the Autoscale group was killing instances before they could come up and register as alive. So I think I had it down to like 30 seconds, which is nowhere near enough time. And further carry on, for our scaling policy, we set it to CPU because that's easy to fake for a demo purpose. We can run stress against the box and just hammer the CPU. The Autoscale group will see that it's busy. It'll kick off another one. Network traffic's hard to fake. For demo purposes, we just decided to go with CPU.
So, just a quick question, because
Yeah.
I typically use CPU, but what do you see some of the use cases, maybe outside of just using CPU?
I think the CPU is the worst metric, honestly, because things can spike a box for any of a number of reasons that are not dictated to the application load. It's very bespoke. It's very custom. You really want to know what your application is doing. You really want to know what's going on. CPU load is the hammer when you really need a scalpel. It's good for some instances. It's fantastic for demos.
Yeah, it's easy.
It's not your go-to in a live prod environment, honestly.
Typically for like a web server, spillover count on the Elastic Load Balancer is a good one because it means that the load balancer is waiting for instances to serve requests. So that's a great one.
Well, spillover count if you don't care about your users.
And surge queuing.
Surge queue length if you do care about your users.
Yeah, exactly. Yeah, one's cheaper than the other too. That's the big gotcha there.
Yeah. So surge queue length basically watches the queue, and if the queue starts incrementing, it'll kick off another box. That means that your users are being satisfied. Spillover count is when a user gets kicked, and then so it depends upon how fast you want to spin up and if you care if a user gets kicked or not. Spillover count is somebody will get a 504, somebody will get some 500 codes. Surge queue length is everybody will be serviced.
Okay, thank you.
Good question, by the way.
Yeah.
Thank you.
I'm not giving you the card though. We have a $100 Amazon EC2 compute card for what? Best question? Standard drawing?
Yeah, I don't know.
Okay,
Something. We'll figure it out.
We'll figure it out. All right.
TBD.
So, okay, so now we're going into the autoscaling group feeds into the target group, and then the target group feeds into the load balancer. So the autoscaling group kicks it off. The target group is then defined. Target group. And within the target group, you've got your health checks. The health check is the thing that you're using to watch the servers that are in the target group for whatever thing it is that you're wanting to look at for health. In here, we're looking at port 80 for a particular file.
Yeah, I think it's just does the web server respond to port?
Just 200.
Yeah.
Okay.
200.
So in the demo, if something comes back with 200, then yay, we're happy, it's good. Most of the time, what you'll want to do is you'll want to embed like a healthcheck.html file in your environment so that it actually responds to the file, not just to a vanilla 200. Okay. And one other thing, this is completely outside of the thing. Tags. Always tag everything. This is commandment number 1. If you have a production environment and you have a dev environment and you have people turning things on, always tag everything. Server sprawl goes way out of control. In a VMware environment, server sprawl went out of control as years ahead. In AWS, server sprawl is like a 7-headed hydra. It's ridiculous how fast things will turn on. If you tag your environment, if you have your resources dictated, like you must always have, key name, owner, variable, user, name, Bob Smith or whatever like that. So we have a rule in our environment. If you do not have an owner tag on an instance or on a resource, it gets deleted in 24 hours. We are brutal. We are Conan the Barbarian with our instances. We do not care. If you do not tag it, if we do not have a throat to choke, that thing dies. And that's me putting my cost optimization hat on. We do a lot of cost optimization. And
You're going to word
sorry?
tag consistently.
Yes.
So that's the other piece of it. If you have a CMDB, then tag consistently. Capital O owner is different from lowercase o owner. You don't want to have 17 flavors of owner in your environment. And that's just my little pet peeve that I always take a pause and talk about. Tag everything, please. It will save you mountains of headaches and mountains of screaming matches with the CFO after somebody has gone off the rails and you don't know why there's $100,000 extra on your burn rate for the month. Okay, where was I? I was on my horse. I apologize. Okay, so the load balancer, the target group then feeds the load balancer. The load balancer is an elastic load balancer, and those are my health checks I talked about. Now we're on to the load balancer. The load balancer itself is obviously balancing the load between the servers that are inside of your target group. You see how this is all tying together and everybody's all swimming in the same pond? It's fantastic. It's very beautiful. So in here we have our DNS name. This is the Amazon provided DNS name that's spit out to us. Basically, we hit the little icon right here, we cut and paste it, we stick it into a web browser, and our environment comes up. So that kind of ties everything together from here. I'm not going to get into security groups. That's a whole other ball of wax.
Can I interject quickly?
Absolutely.
So for an elastic load balancer, it's important to note you only get a DNS entry. There is no IP address, no elastic IP address, no IP address of any kind associated with Elastic Load Balancer. So you will get this unfriendly DNS name by default from Amazon. You would then use a CNAME or an alias record if you're using Route 53 for www.greenpages.com or .vmware.com or .company.com, whatever. So that's an important note, is that you can't assign an elastic IP, you don't get an IP address. You will never know what that, and that IP address can change at any given second. So don't go resolving that IP and then using it, because it's not going to be yours very long.
And that's actually a common thing that we've seen. We've had customers ping that, get an IP address back, and then whitelist that IP in a firewall, and then it changes like 3 seconds later. And they're like, why this was working 3 seconds ago. Why isn't this working now? And then we have to do root cause analysis and try to figure out, oh, you whitelisted an IP address. And that's a learning curve.
Actually, it's why did you whitelist this IP address? Where did that IP address come from?
Actually, yeah, that was, I was like, what is that? Why does that even exist? Okay, so now we're going to tie the whole thing together. We're gonna play a game I call Be the Packet, where we're going to start from the end user, and then we're going to go all the way down to the web server. So. What? I'm sorry, what? Oh, how did that, oh, that's so embarrassing for me. Okay, so the end user gets on his laptop, he says, I want to go to the website. The website then does a DNS resolution, figures out the DNS entry of the ELB, hits the internet gateway, travels down to the Elastic Load Balancer. The Elastic Load Balancer then looks at the target group. It does the health check monitor of the boxes, sees which boxes are up and running, sees where it routed the last bit of traffic to server A or server B or server 7000, and it says, okay, this next server, which I see is healthy, is now the next on the list. The ASG is also on the back monitoring and watching the boxes. So here's and it's looking at the boxes and it says, okay, this user is the user that made my CPU on the very last server on the list go from 79 to 80% CPU utilization. Now I need to spawn off another box. The box gets spawned. You have your 300-second balance health check grace period wait time. That's the name for it. Yeah, grace period. And then that box then comes up. And by then I've already been on a box and everything, but now the new box is up and it's ready to be, I mean, it's after 5 minutes, so the next person after me will then be able to hit that new box. Right? And it's just scan policy decide if yes or servers. I intentionally misspelled that. And so the new instances are now spun up, the launch config takes care of it, spins it up, attaches it to the EFS, mounts it, everything's happy, it registers with the ELB sees it, and now we've got another launch run. So that is everything from here up. Mr. Jones, and this is actually the hard part, so he's smart than I am. He'll take care of this part. He's also my boss. So, gotchas. So, if you guys haven't seen the hashtag AWS Drinks, and you've spent a lot of time in AWS, this is hilarious stuff. This is like meta nerd humor right here, and I laugh. We actually send these back and forth to each other all the time. They're stupid to anybody else. But if you know Autoscaling Groups and you read this, you're dying right now. You're in stitches. So what this means is your friends, you order a beer, 20 friends join you, the bartender dawdles about, your friend gives up and leaves, the bartender shows up with 80 drinks. What that means is a whole bunch of people hit the website. Your ASG was poorly balanced. It did not spin up the boxes in a sufficient amount of time. Then all of these resources light up after all of the users have left. Hashtag AWS Drinks. I highly encourage you to check that out. So, how do you prevent this? The first thing that you do is you make sure that you never use a regular vanilla golden image AMI from the marketplace. If you have a thing that you're trying to do, and there's a bunch of, like an application, if you've got a bunch of code that you need to prep, you do not want to use a launch config to prep your box for the vast majority of your stuff. If you are going to be running Apache and you know that all your boxes are going to have Apache, install it on the golden image, and then snap that and use that as your AMI. Get that box as ready as humanly possible for the launch config to do just the last little bit. That last attachment to the EFS, the last sync with an S3 bucket of rapidly changing files. What's another thing that we do?
Yeah, keep it updated as well, because if you're running Yum update or whatever,
Yeah.
that obviously takes time. So if you built the box on January 1st, it's out of date and going to take forever to keep updated. So keep them updated as well.
Right, and that goes. So your AMI will update as you go, and you can do that quarterly, or you can do that every 6 months, depending upon your change schedule.
vSphere templates, same thing. Keep them up to date. Keep them with your typical tools, your typical.
Yeah, same concept. For those of you that know.
Yeah.
The next step is give your instances sufficient time to come up. So this is your grace period, your health check grace period. Linux boxes come up a lot faster than Windows boxes. So if you're spinning up a Windows box and then you want to turn on IIS, and you want to do all the things with it, you want to add it to Active Directory, you want to install Office for some ungodly reason, I don't know, whatever you want to do it on it, you have to have a grace period that's going to be sufficient for it to do the things. Actually, installing software is a bad idea, a bad example, because that's what you're going to do here. Just make sure that you're spending a lot of time in your dev environment tuning your grace period health check time, because your mileage will vary depending upon the operating system. And the last one is to tune your health checks. So like I just said here, what you're using, don't use ICMP. Use a valid health check metric that is relevant to your application workload. It'll be literally different for almost every Autoscale group that you have.
Actually, go back one more.
Yes.
So, real world example for the sufficient time to come up. It's a delicate balance because you want to get the instances up as quickly as possible, because if you're experiencing a scaling event, that means there's a good chance your users are not being serviced properly. So you want to get those instances up as quickly as possible. You don't want to, for example, sync 100 gigs of images and code from an S3 bucket onto your new instance.
Who would do that?
So that it can get up and serve your website. You want to keep that up to date. You want to use like a sync command so it only moves or copies the stuff that's changed. But you do have to give it enough runway to get built before the health check realizes that it's no good and starts to turn it. So it's a delicate balance. It's not just about tuning it or minimizing. It's about making sure that it's big enough to get done what needs to get done, but small enough to do it efficiently, so you're not standing around holding 80 beers when everybody's left the bar.
And that delicate balance actually changes over time. So you want to make sure that you're looking at, back in the Autoscale Group section, there's an active history, and it shows you how often boxes are being spun up and how often boxes are dying. Activity history. That right there, spend some time in there, get to know that. A lot of our customers have email alerts when things are dying and when things are being brought back on. It gives them really good visibility into it. Or you can do an SMS queue, or you can, some email, it doesn't matter. However you want to be alerted to it, that will give you an idea of where you are in terms of that delicate balance.
Have you guys done any elasticity studies on Linux systems versus Microsoft?
Well, in terms of what?
Scaling, everything.
I can tell you SysPrep takes
Anything
forever.
anything at all. Any kind.
That's so. As in my VMware days and with my VMware customers, I can tell you, you get complaints about it takes forever to deploy a Windows machine, a Windows server. It takes 20 minutes, and you look at the history, and literally 30 seconds will be the cloning and the powering on. 20 minutes of SysPrep. VMware does a great job. They can't do that. They can't fix SysPrep. So, you have to give yourself enough lead time for SysPrep to run and all the other stuff to happen, because you have to sanitize that box. You have to give it a new SID. It's got to come up and be its own system. So that is going to add some lead time to your scaling event. If you're running a website on IIS and it's getting hammered, you might want to actually. What I would recommend doing is run more servers with a lower trigger, autoscale trigger. It's going to burn some additional cost, but it gives you a little bit of room to grow.
And in terms of your elasticity question, in general, it's easier to scale a Windows box vertically rather than horizontally. Yeah, you're going to have to bring the box down, and yeah, it's not really,
Ideally, it's fine to load balancer, it won't matter.
Yeah, Dave's actually going to get into like the definition of elasticity in a second here. So it's not, that is a loaded question, and we will be glad to talk to you in depth about it afterwards.
There's actually a large community out there that will tell you that SysPrep in Windows boxes is not really necessary.
Yeah, you're right. You're absolutely right, especially around SQL, especially with SQL servers. Yeah.
So when you're talking about auto-scaling Windows boxes, that may be, look at your own private environment, and that may be something you may not even have to do.
Yeah, especially if it's like a web server and it's not going to be joined to AD, ideally for security reasons. Yeah, you probably don't need it.
And that's the classic example of a good horizontally scalable box from a Windows perspective.
we're all afraid of duplicate SIDs, but duplicate SIDs is actually a myth within the Windows community.
Did that answer your question? Most importantly. Okay.
We can get into the gory details outside of this.
Yeah, we're not going anywhere. So. All right, so I'm in charge of RDS. Lord, RDS. I don't. So RDS, for those of you who don't know, it's Amazon's relational database services. It is database as a service. 6 flavors. I'll get into them in a bit. We'll discuss the differences and everything. But Oracle SQL, MySQL, MariaDB, Aurora, and Postgres. Did I get them all?
Yep.
I think so.
You're
Thank
the
you.
expert. Why are you asking?
I don't know. Whoever said yeah, but I hope you're right. Okay, so I'm actually not really going to talk about RDS from a 101 standpoint. It's probably a 102 discussion. I'm going to talk high availability versus scalability. So and they are two very different things, and that is like the most important thing you need to take away from today is that high availability, scalability, totally different. So from a high availability standpoint, RDS offers multi-AZ deployments, which essentially means when you deploy a machine, an RDS instance, or when you go back and reconfigure an RDS instance to be multi-AZ, it automatically creates the master, writable, accessible database, and the standby database. Now, they will always be in separate availability zones, hence the name multi-AZ, but they must live within the same region, and that's important. What? Yes, that's what that means. It is a synchronously replicated database, so the write is not considered committed until it's written to the standby as well. That's also important to note. It's high durability. That's the whole goal, name of the game. High availability, high durability. So this provides us obviously with data redundancy. Duh. That's the whole point. It eliminates I/O freezes for things like snapshots and backups. So when you have a multi-AZ database and you go to take a snapshot of it, it's not going to freeze the I/O on the master database. It's going to freeze the I/O on the standby, and it's going to do all of its operations off the standby, so your master is still free to service requests. And it's also going to minimize latency spikes during those maintenance operations. So, while data is being backed up out of that standby, your master is still there humming along as if nothing's going on. And this guy is an expert, by the way. He's like shaking his head and answering all my questions, so he lied earlier.
No, you asked about ALBs, you didn't say data.
Fair enough.
Gotcha.
Feel free to call me out if I miss anything.
So far, so good.
So, the really cool thing about this is RDS handles the failover for you. You point your application at a DNS endpoint, and Amazon handles the health checks on that endpoint. It makes sure that the database is up and running, responsive. If it detects any kind of failure, it will flip over to the standby instance. So in this case, we're talking AZ outage, US East 1, it happens. Primary database instance fails for whatever reason. If the OS crashes, if MySQL crashes, whatever. If the database instance database classes change, so if you go from an N4 large to an N4 extra large, that's going to bring the instance down temporarily. It will flip over, service request from the standby, actually making it the master, and then it'll flip the new instance over. The operating system is patched on the RDS instance, or you can actually trigger a manual failover by rebooting and checking the box to reboot with failover, and it will actually flip over. You can form a manual failover for maintenance or testing or whatever.
Speaking of testing, is anybody here getting ready for the AWS exams, either associate or pro?
This is huge.
That might be something you want to drill down into. Reboot with failover. Just throwing that out there.
Without violating the NDA.
Without violating any form of NDAs, of course.
So, I don't like to talk to the slide deck or anything over there. So in this case, we have our application. It is an Autoscale group per Chris's icon.
Yay, Visio.
We have our master running in, let's call it 1A, and our standby in 1B. 1A gets nuked. don't know what happened, maybe maybe an overzealous admin committed a change that he shouldn't have. RDS will actually flip the application over to look at the standby, making it the master, making it writable, making it fully accessible, and everything goes on. Now, in my experience, there is a bit of a delay. You know, it takes time to sense the outage, to make the change. And then, once the issue is resolved, it makes the former master the standby. If we're talking a bigger issue, it will spin up another standby and another AZ if it needs to, but it will heal itself.
Chris, what if you have an application that can't support that timeout before the flip?
Then you'll probably have to restart your application and undated.
No, I'm asking seriously.
Oh, yeah.
You know, because it can be up to like a 3-second delay, right?
It can actually, I've experienced personally longer than that. Yeah, so usually the application will fail and you'll have to address it at the app.
Is there not a caching technology available?
I mean, you could use, so we do actually have, read replicas can help, because they will continue to serve read requests while, jumping ahead, but yes, read replicas can help because they can serve read traffic while your primary instance is down. You could use like Memcached, Redis, Elasticache, largely, but that's kind of out of scope for this discussion.
Right.
Any other questions? That was a good one. Okay, so this is my only wordy slide, but it's kind of an important one. It's the gotchas for multi-AZ, and I need to walk back over here so I can not read these directly to you. When you use multi-AZ, you have increased write commit latency. I mentioned that earlier. The write is not considered written until it's written to both the master and the standby for durability purposes. So the extra time required to make that second write across an AZ boundary, while minimal, because we are still talking AWS's high-speed backend network, there is additional time there. Similarly, you can have increased latency when your application is running in 1A, but your primary database instance is in 1B. It still has to cross that AZ boundary, so you can still experience some additional latency. And then for production workloads, AWS recommends you use provisioned IOPS. Guarantee that IO, and that you use sufficiently large, they specifically call it M4 or larger, instance classes that are optimized for provision IOPS.
Can I interject right there?
Absolutely. I need
So,
need some
you
water?
need to drink water? Okay, perfect time. So the AWS recommendation for provisioned IOPS is something that we've, provisioned IOPS are very expensive from a disk perspective and from a money burn perspective. There's a lot of ways that you can get around the official Amazon recommendation of PIOPS by doing a number of things. You can size your EBS volumes larger and to give yourselves up to a maximum of 3,000 IOPS per volume. You can also do some monkeying around with RAID arrays, software RAID arrays within the operating system itself. So we've actually gotten some better performance rates. Not better than ephemeral, because nothing's going to get better than ephemeral, but you can actually get really good consistent read-write rates by stacking 3 or 4 terabyte EBS volumes of regular drives, not PIOPS, RAID 5ing them on the OS software layer, and then basically getting an aggregate crank of like 9,000 plus IOPS for regular vanilla EBS volumes at a fraction of the cost of PIOPS. So that's something that we've done, and it's yes sir.
If you're doing for the database,
Yep.
you can get away with a small provisioned IOPS just for the log.
Yeah, well, so
With your data
MDFs,
somewhere
LDFs, and
else,
T-logs.
You're going for
Yeah.
latency.
Oh, totally.
I mean, if you're trying to minimize that conversation,
Yep.
provision the small log and just in and out, put your data somewhere slow.
Like in the physical world, putting logs on RAID 10 and data on RAID 5.
And so we've basically done that exact same thing. we've toyed with using ephemerals for that, and then doing a flush, doing an immediate flush over to persistent storage. There's a couple of schools of thoughts on that, and I know why you cringed. So I totally.
I'm a DBA turned architect, so yes, I have to cringe.
So the breakout of MDFs, LDFs, and T-logs is something that we play with a lot, and the cool part about this is that you can literally strip down and spin up boxes 1,000 times a second if you wanted to, and test all the different. I actually have a spreadsheet of that. Okay, we stacked another EBS volume, non-PI ops at 500 gigs, and then run a task, and then stack another one on, do RAID 5, do RAID 10, do RAID 0. It's very nerdy and very, it puts my wife to sleep. Like, oh, I got more apps. She's like, okay, good, go to sleep. But it's if you want to chat about that, we can certainly do that. It's fun stuff. Sorry.
No, you're good. No. And then the most important, in red text, high availability is not a scaling solution. This is a DR, HA, data redundancy solution. This
He's
is
wagging
not
his finger,
scaling.
so you know he's serious.
Yeah, this is. You cannot serve traffic read or write from that standby while the master is still alive. It is still a single node as far as the application is concerned. All right, so moving on to scalability. So read replicas, read replicas, read replicas. Amazon read replicas provide enhanced performance and durability, asterisk. They allow you to elastically scale. Now, Chris's elastic and my elastic are totally different. RDS is not going to automatically scale read replicas. It's not going to create additional automatically in response to a load. It is a manual process.
Oh, I thought you meant we were arguing on the definition of elastic.
No. ASG elastic versus RDS elastic.
Oh, okay.
Totally different
All right.
concepts. If you are experiencing read delays, read latency, deploying read replicas, especially closer to the source or the application, absolutely can help increase read performance. You're still stuck with a single write node, but you can serve that read traffic. Make sure I cover everything on here. So you can create one or more. I think it's up to 5 direct descendants for read replicas. It allows you to essentially increase the aggregate read operation. So we can spread, and I've got a larger version of this on the next slide. But what it allows you to spread those reads out. Bottom line. And they can also be promoted to standalone databases in the event of failure. So they become a new instance. They get new endpoints. Applications will need to be reconfigured. But if you lose an entire region for some reason, you could promote one of those read replicas out to a full database. Yes, sir.
When it gets promoted, does it change from sync to from async to sync?
Actually, so it becomes a standalone database. It's no longer associated with the master database.
So it doesn't sync with anything?
It doesn't sync with anything. At that point, it's a new instance, essentially.
You're cutting the cord, and now this is its own thing. So
You can then add read replicas or multi-AZ to that one that you've promoted.
So you have to rebuild the whole sync process again? Okay.
with other new read replicas that
Yes.
you push out.
So there's no true recovery.
There's no
once
true
that
what?
happens.
No true what?
There's no, excuse me, there's no true recovery once that happens. It's almost a redeploy.
Recovery of what?
So after you go, you take and turn it standalone.
Yep.
After that, you pretty much have to redeploy.
Yeah, you basically point your application to that new instance and then redeploy the read replicas.
A lot of times what we'll see in the wild is you'll have your read write and you'll have your read replica, and then they'll break that off, and that read replica then becomes like a dev environment that then they'll attach their dev boxes to and tool around with that. And while that's happening, they'll have created another new read replica of the master, and then they'll just basically snap and break off that guy as they're testing new things. So it's not blue-green by any stretch. It's just it's taking your prod, turning it immediately into a dev test sandbox playground, and then trashing it and then starting over again.
So you have a maximum of 5 read replicas per master, but each read replica can have read replicas. And you get into, But what can happen, what you have to look out for is latency. You know, from the time the write is written on the master till it gets down to one of those grandchild read replicas, there can be a significant amount of replication. So something to keep in mind if you were to ever go down that path. Yeah, no, we're taking it up too much time. So and then I mentioned durability earlier. Like I said, these can be promoted, so they can be used to complement multi-AZ architectures. And then I don't know if you guys can see this. But what we have is essentially our master is in US East 1. We've got read replicas in Oregon, South America, Sydney, Tokyo, and Ireland. And they're all reading locally but writing globally. So, you know, think a great use of this would be something like a forum software. Most people do reading. A few people, you know, the reads are a whole lot heavier than the writes. You don't have a lot of folks posting. I mean, you do, but you know, as far as the post versus reads, you've got a lot more reads. So it's a good example of how this can scale to global. I mean, this is literally global at this point, and we've got a better set of this. Yes.
You mentioned reads are harder than writes, right?
Not harder.
Well, depending on the application, there could be more read operations than write operations.
Yeah, but
Yeah.
performance-wise, read operations are always less memory intensive or CPU intensive.
I am not. That's a question for the DBA. I cannot speak to that.
It depends.
Yeah. That's,
Nice answer. Are you an architect?
I'm honestly not qualified because I am not a DBA. All right. So when do you use read replicas? Obviously, it's got to be supported. So we're talking Aurora, Postgres, Maria, and MySQL. The two expensive options don't support it.
What was it?
Oracle and SQL.
Yeah.
So, so obviously, when you need to scale beyond the compute or read capacity of your single instance database. Again, I mentioned earlier, to answer your question, Ray, it can serve read requests while the master is down. So if the master is being snapped, you know, if you don't have multi-AZ and you're snapping it for a backup, you can still serve reads during that I/O or that I/O freeze. And then for business reporting, those of you interested in taking one of the SA associate or professional exams, reporting, read replicas, the two R's go together. All right, so then the comparison slide. Scalability does not equal high availability. On multi-AZ, it's synchronous replication. Read replicas are asynchronous. Multi-AZ, only the primary database engine is active. Read replicas can be accessible at any time. Automated backups are taken from the standby in multi-AZ. By default, there are no backups on read replicas. Ideally, they could easily be rebuilt from the primary. Multi-AZ always spans two AZs. That's pretty easy. Read replicas can be within an AZ, across multiple AZs, or across regions. The database engine version upgrades happen on the primary and the multi-AZ, and they generally don't happen on read replicas. And then automatic failover to standby when a problem is detected, and read replicas, like we said, can be manually promoted to standalone instances. So this is the part where it gets interesting with the live demo. Quick and dirty, this is the architecture of the demo environment. We've got our Elastic Load Balancer, our Autoscale group with our web servers spanning two AZs, RDS master standby, and then all of my like 100 lines of PHP code live on the EFS so that I don't have to copy it out every time it's deployed. And fun fact, this environment looks like this is a CloudFormation template. It's 600 some odd lines. How many?
637 lines.
There you go, 637 lines of code. So
We used CloudFormer to rip it down, and then tweaked it out and stuffed it back up and tested it in both of our demo environments.
all right, so
So you're a CloudFormation, not a Terraform shop?
So that is also a loaded question. We have proponents on both sides. We like Terraform because you can deploy it to using both Azure and AWS. but we're not here to talk about Azure. We like both. We don't generally pick a tool. We let the gig dictate where we go with whatever, even to the point of picking the right cloud. It's never a, oh, this is what we're going to do hard and fast every single time. It's always tool dependent.
All right, so we're running low on time. Chris, the problem with this is Chris and I can talk about this all night. So we're doing the best we can to slim it down. So I currently have 2 demo web servers. If you can read it, I don't know if you can. One's running in US East 1A, one is in 1B. If I jump over to my little web demo, A signifies that we're serving data off of this server in
So you click
availability zone.
You click I'll be banner.
Yeah, there you go. So, and we're pulling this data simply from the AWS EC2 instance metadata. That's all we're doing.
So note the IP, we've got 11.168.
And it's in serving an A.
We've also got a timestamp down here too.
So if I refresh the page, it may or may not, now it's going to flip over to B. And if I refresh the page, it stays with B. We're back to A. All right, so now let's have some fun. I'm going to take, what are we on right now? All right, so we're on A, so I'm going to kill A.
11.68.
All right, so I've got A selected. Let's just terminate that instance.
He's dead, Jim.
I thought we were in Nuke and AZ.
I think Amazon would take exception to that. Terminate.
You don't have termination protection?
Not in the demo environment, man.
First games.
We'd be here all night. All right, so we're back over to B, and I fully expect we're still at B. Still on B. We may see a 504 gateway timeout error, but it looks like we're actually we're going to avoid that. So we're going to stick on B for a while.
Nice.
I wish I had the auto refresh plugin on Chrome installed right now. So this is going to run for a little while, and we're gonna see here. It takes about 2 minutes. In my testing, it takes about 2 minutes before the ASG kicks in, and we should be able to come over here.
So right now the health check is pinging the boxes. It's
Not
getting,
pinging the box.
I'm sorry, it's checking the boxes.
Pinging the box.
It's not ICMP. I apologize. I just say ping when I mean looking at something. The health check is checking for the boxes right now. Based upon the level of sensitivity to the health check, you can set it down for a minimum of 2 second checks twice before you fail over. That health check is now going through. It's evaluating that we have a bad instance. It's making the determination that I can't get to it. I now need to look at my scaling policy. The scaling policy says, hey, I need a minimum of a desired instance level of 2. Go kick me off another box. The ASG looks at the launch config. The launch config then says, okay, this is your AMI. This is what you need to do. This is the launch config. It runs it with the Autoscale group, and presto!
So you'll notice this instance is terminated. It's terminated.
Oh.
It's dead. Nope. That's the Bastion notice.
Still
You got all
waiting.
excited about the
Still
Bastion.
waiting.
But our Autoscale group, last time I was over there, it's probably going to have changed by the time I get back. Still says that everything is healthy. Oh, now it says it's unhealthy. So we should actually see our new instance pop up over here. We're still serving traffic successfully out of US 1B. This is the fun part of the live demo.
Yeah, we were trying to figure out what's
Vamping until
what's a
something
good thing
happens.
to like riff on while we're doing this part as we wait for this thing to respawn.
So while we're waiting,
Questions?
well, actually, no,
No?
we're not.
Okay.
Well, no, I will take questions, absolutely. Oh, wait. Yeah, okay, cool. Wow, that's cool.
Yeah.
I duplicated the screen, put PowerPoint into a presentation mode to jump on that. So what can we do with this? So I showed you the 2 AZ. This just covers 2 availability zones. It protects you from a data center failure from an AWS perspective. We can actually expand it out. This covers all 6 AZs available in Northern Virginia. We can spread web servers across 6 AZs. We still have just our master and our standby. Fun fact, if you choose multi-AZ when you deploy your RDS instance, it will not allow you to specify availability zones, so they can end up generally everywhere. I can tell you the 3 or 4 times I built this, they basically, primary was in 1A, secondary was in 1B almost every time. Actually, I think it was every time. But we can spread this out as far as we want to go. You can, obviously, US East 1, Virginia is the only one with 6 AZs right now. As of 7:33 on May 22nd.
Mileage may vary, could change immediately.
So, but we could take this even further, and kind of as I alluded to in the, yes.
Before you get into that, I also wanted to point out the Bastion host. So one cool thing that we do is we actually have a single instance Bastion host hung across the multiple AZs as well. This has an EIP on it, so if this box dies for whatever reason, if you have a hardware failure or anything like that, it will spawn up randomly somewhere along here with the same IP address. So your Bastion host into your environment is always the same. Same PEM key, same external IP address, and effectively it will never die as long as, as long as the entire config doesn't blow up. So that's the reason why we also have an Autoscaling group for the Bastion host as well as for the web server farm.
And that's an ASG with a min of 1, a max of 1, and a desired of 1. So it'll always have one instance that is checking healthy per our ASG health check. So we can actually take this multiple steps. I say a step further, multiple steps further, and we could span the globe with our web application, quite literally. We can have this sitting here in Northern Virginia. We can use Route 53 and either geo-based routing policy, latency-based routing policy, whatever, to send traffic to any one of our remote sites. And this only shows 6 different regions because of, does anybody know why I only have 6 regions populated?
Showing 15 would make your map look ridiculous.
That's another reason.
Did I hear 5 replicas of the master?
Yes.
Exactly.
Yay,
We have our
somebody's
master
listening.
plus 5 replicas. Somebody was paying attention.
Where's my AWS flag?
Doris?
All right.
So you were the one person that was listening.
He's still awake. He was drinking soda.
Right.
All right, so we can now see that we've got another demo web server spinning up in 1A. So if we go back over to our web demo, it may or may not trigger over to A. It's pretty quick. Basically, as soon as Apache comes up and responds with a 200 status on port 80, it takes it back over. So that's our quick and dirty.
It works. Yay! Stop.
So, questions, discussions.
I've got a question.
7:35, I know where